Good afternoon, good morning, good evening. How are you doing? Are you doing well? I take this chance to welcome you to Ambassador Speaks lesson, and today we are still discussing chemistry lesson. We've been discussing chemistry for the last 2 weeks. I'm still yet to find time to discuss physics and other subjects, but every 3 p.m. we are discussing chemistry, and I'm glad that you have always been joining this lesson in my student all through this particular time. And I would like you to confirm to me whether you can hear me, where you're watching me from, so that we can discuss. From the description that you can see in your laptop there or in your phone over there, I've said we are going to discuss properties and trends across a period. And the facilitator is Ambassador, myself. So now, someone to confirm my audibility, if you can hear me very well. There is nothing like you are talking and nobody is listening to you. Somebody, just one person, confirm that you are audible. I just want that one thing, that we can hear you, we can listen to you, so that I can get enough confidence to proceed. Yeah, and we say that one of the challenge I'm giving you is when you join a lesson, please stay until the end of the lesson. Hii maneno ya kuja for 2 minutes tunaenda. Just concentrate. One of the ways to pass exam is concentrating, and people or most students lose their mind because of lack of concentration. But because I've told you, concentrate until the end of the lessons. Remove any distraction, remove anything, any object, any gadget, any person who can become a distractor in your lesson. Just be alone. Ensure that you are around. They should keep quiet. Tell somebody who is near you, keep quiet. Yes. So yeah. Now I would like us to discuss properties and trends across a period. And whatever I'm going to discuss across period 3 applies across the other periods. Only that we cannot repeat ourselves discussing all the periods. The syllabus, that is the KIE, decided to only pick one period, which is period 3. But the way we are going to discuss period 3, it is going to apply across all the other periods that we are going to have. Nowadays, I've seen examiners doing this. They discuss, okay, in the syllabus we are teaching period 3, but in the exam they will ask you questions on the other periods. But the mechanics and the applications is actually the same. As long as umeelewa kwa ni kama ile ya alkali metals. As long as you've understood the trends in the alkali metals, the rest becomes simpler and easier for you. So what is there is, now today we are only dealing with one period, and that is period 3. We are going to see all the elements across the period. Yes, okay, ready for the lesson. Proper. Trends across across a period, but for the sake of learning, we are only going to consider period 3. Period 3. So I want you to ask yourself, what are the elements in period 3? What are the elements in period 3? First of all, Just a minute, we are fixing something here. Okay. Those who are in class, keep confirming to me whether you can hear me very well. We are proceeding. And I've said that in period 3, what you need to know is the elements present in the period. So now, it tells us in columns, those are groups. But now, the ones that we are going across this way, these are periods. How do you identify periods? You identify period by looking at the number of occupied energy levels. The one with one occupied energy level, those are period 1. It is only hydrogen and helium on the other side. Ikiwa na mbili, those are period 2. Now, in our case, the ones which have 3 occupied energy levels includes 281, 282, 283, 284, 285, 286, 287, and lastly 288. So you see, that is period 3. So sasa kazi yako ni kujiuliza which elements has an electronic arrangement of 281, 282 hivyo mpaka huko mwisho. Timothy, you can just start by asking yourself, what could be 281 ni nini, 282 ni nini, 283 ni nini, fix mpaka mwisho. Those now are the elements across the period. So this one, the first one, 281, this is sodium. And this is metals, and this is aluminium. This is called metalloid. I'm not saying the element is metalloid. No. This element is silicon. That's how it should be. At number 15, 285, see number 15. That is phosphorus. Then we have sulfur here. Then we have chlorine. And lastly, argon. Those are the elements across the period. One common thing is they have 3 occupied energy levels. All of them. The only thing that varies is the number of, which is the atomic number, the number of electrons. So that's what only varies. Hii nimeandika metalloid kwa nini? The first 3 are metals. Now, the last ones, 4, starting from phosphorus, sulfur, chlorine, and argon, those are non-metals. Now, silicon is called a metalloid because its properties are found in between those of a metal and a non-metal, silicon. The other counterpart of silicon that behaves exactly like silicon is carbon. Carbon behaves like silicon, and that is how it should be. Now, this is what we are supposed to discuss in our today's topic. Now, nataka tuanze na kitu inaitwa the atomic size. Atomic size. Trends of atomic size across period 3. All of them have 3 occupied energy levels, but the atomic size are not the same. Yeah? So how do they vary across the period? Ukienda hivi, do you expect the atomic size to increase or to decrease? That's a good question, a good challenge, which I would want you to ask yourself as I'm going to explain to you. Now, a student once wrote to me in one of the exams I gave to her. Akaniambia, all of them have the same size. Reason is because they have the same occupied energy levels. That reasoning is good, but it requires something else. By the way, Timothy, I've sent your exams, the hard copy exams. Ikikufikia uniambie na ufanya haraka haraka ndio tufanye marking. Umesikia, Timo? Now look at this. Ask yourself this question. What holds together the energy levels? What holds together the atom in place is what we call nuclear force. And this nuclear force comes from the nucleus. It is produced by the protons. Are you together? Now, lazima ujiulize, yes, they have the same number of occupied energy levels, but do they have the same force of attraction from the nucleus? And the answer is no. They don't have the same force of attraction from the nucleus. As you move across, ukielekea mahali ako niko, the protons increases, which increases the force of attraction. That is the nuclear force or the nuclear charge that pulls them towards the center. Now, as you are moving across, yes, that force increases. Meaning, as you are moving across, there is a greater force holding the atoms towards the center of the nucleus. Now, my statement is this. As you move across, the atomic size decreases. The atomic size decreases. Ukienda hivi, inapungua, ina decrease. Reason, there is an increase in the nuclear charge as you move across. What increases the nuclear charge? The increase in number of protons as you move across the period. Siapo tuko pamoja. Yes, I hope up to that point we are together. Kama uko na swali, niambia haraka haraka as we are moving on. The other thing again that we need to ask ourselves, let me ask this question. Name for me 3 elements in period 3 that conducts electricity. Name 3 elements in period 3 that conducts electricity. Give reason for your answer. Give reason for your answer. If you are told to name 3, name sodium, name magnesium, and name aluminium. Reason is they have delocalized electrons. They have delocalized electrons. Name 3 elements that conduct electricity: sodium, magnesium, aluminium. Somebody will ask you, of the 3 that you have mentioned, which one is a better conductor of electricity? You will say aluminium. Why? Why is aluminium in this case, when we compare these 3? Why is aluminium now a better conductor of current than magnesium and sodium? Is because it has 3 delocalized electrons. These 3, 2 and 1 for conduction of current. The more it has, the more it's a better conductor of current. Good. Then that's the first question that I was asking. The other question is, I've explained about the trend. As you move from sodium to aluminium, the trend of electricity conduction increases. Yes. The others do not conduct electricity. Why? And this one you will be asked. From phosphorus ukielekea huko, they do not conduct electricity. Reason is molecules. Kuanzia hapa, they are made up of molecules. Ama they have molecular structure which do not allow them to conduct electricity. So now, what am I saying? Okay, anzia hapa. Silicon, for those who are studying physics, and those who will study physics up to Form 4. The last topic of chemistry or physics, that is, silicon, is studied there, and it is termed to be a semiconductor. A semiconductor, it means it is a conductor sometimes, sometimes it's not. Depending on the external conditions like temperature, silicon can be a conductor or a non-conductor. It depends. Under very low temperatures, non-conductor. Under very high temperatures, a conductor. So we call it a semiconductor. Allow me to mention another element that is a semiconductor is an element called germanium. Germanium ama germanium. Hapo tuko pamoja. Yes. Now, the other thing that I would like you to know, we are just still here. I would like to, I think I've talked about atomic radius across the period. Tumesema it decreases because of the increase in nuclear charge. Sawa. Now, explain, let me post this question hapo kwa chat section ndio tusome wote. Let me place it there. The question is, explain the trends in melting points and boiling points across the period. As you move across the period, explain. Now, is your kama ya groups at the alkali. This one, that question that I've just posted there on the chat box, you can see it on your screen. Explain the trends in melting points and boiling points across the period. We cannot have one explanation that cuts across. No, we will have one explanation that cuts for metals and another one that cuts for non-metals. Unajua hii period, it's a mixture of metals and non-metals. So if I tuanze na metals. From sodium to aluminium, the melting point increases. Why? You allow me to explain it in this manner. The melting point increases. Why? Look at this. Kuna kitu kinaitwa metallic bond. Yesterday I was telling you, anytime you are asked about boiling point and melting point, just to know that you cannot explain that without mentioning bond ama structure. These three, sodium, magnesium, and aluminium, have metallic bond. So we need to ask ourselves, of the three, which one has a stronger metallic bond? Which one has a weaker metallic bond? Aluminium has a stronger metallic bond. Why? It contributes 3 to the. So sodium is the weakest, has the weakest metallic bond. And aluminium has the strongest. So melting point inachangeable, inaenda ikiongezeka. Now, wachana na silicon. Silicon is a special case thing. I will say something about silicon after this. Now, from phosphorus ukielekea huko, the melting point decreases. The melting point decreases. Anybody with a question? Niko na swali lingine. Okay, though you may explain, but I'm just asking how you can be asking an exam. Examiner can decide to ask you, why is the melting point of aluminium higher than that of sodium? Why is the melting point of aluminium higher than that of sodium? Has a stronger metallic bond than sodium. Then another person can ask you, why is aluminium than sodium? Because it contributes 3 electrons to the sea of electrons. We call it sea of electrons. Angalia kwa metallic cloud of electrons. You get me? Now, and this question is very common, and you will meet it in your exam. Don't say I'm a prophet. I'm not. In fact, I'm not even a rainmaker. There's a question I'm posting here. There's a question I'm placing it there. Silicon and has a much higher melting point than all the other elements in the period. Explain. Hiyo nayo ni swali mzuri sana. You will see it on your screen there. Silicon, a non-metal, has a much higher melting point than all the other elements in the period. Unajua sasa, silicon always plays a very safe game. Ikiamua ipatikane kwa metals inapatikana, ikiamua ipatikane that side inapatikana. It's called a metalloid. Now, but most of its properties lie on the non-metal side. But now, why is that it has a higher melting point than all the other elements in the period? What you are thinking? I always love scholars who think a lot. I love scholars who think a lot. Because no one is here to answer me. Anybody who is there to answer me? I'm waiting for you. Of course, anytime you ask about melting point, compare, you only have one way to explain that. Use structure and bonding. Can you tell us that silicon has a giant atomic structure with a very strong covalent bond? Wacha nikuandike hiyo. Hiyo nayo wacha nikuweke kama answer. Waweke hiyo nani? Waone your answer now. That is what I wanted to write. Silicon has a giant atomic structure in which all the atoms are held together by very strong covalent bonds. Hiyo ukiandika kwa mtihani, in fact mwalimu atakuita kusalamia, akwambia bwana, your reasoning is on top notch. Sawa sawa. Aya, kidogo nione kama kuna comments kwa theater channels. Nione kama kuna. I told you we have 4 channels. Okay. I think everybody is well now. We proceed. You've understood why silicon is having a higher melting point. Here it is a non-metal. So it needs a lot of energy to break those bonds. Are you together? That's why it has high melting and boiling point. Are you together? Swali lingine, why are boiling points of chlorine and argon very low? Why are boiling points of chlorine and argon very low? By the way, they're very low. Yeah, I know that they're gases, but you cannot give your reasons that they're gases. In your statement, yes, mention that they are gases, that chlorine and argon are gases. But their molecules are held by weak van der Waals forces. Yeah. So it is easier to break weak van der Waals. Somebody was saying this name weak van der. Tenimalizia hapa. Weak van der Waals forces. The name itself is not weak. Kitabu uandike jina kama hii, that name is not weak van der Waals forces. They require very little energy to break. Are you together? Weak van der Waals forces. The other thing that I can say, chlorine is diatomic, while argon is monoatomic. You understand what I'm talking about? So, now, kidogo, there is something kidogo ndaga tuangalie. By the way, lesson ya leo haitakaa sana, it may not be more than 1 hour or even in the next like 10 minutes tutakuwa we are finalizing, because we are just dealing with properties and trends across a period. So there's something small I want to discuss, then we look at some questions. Yes, Timothy, I've seen your comment. Now, I wish I was able to draw a table, but I cannot draw a table right now. Now, but let me ask this question very fast. We have our elements here across the period. How do they react with oxygen? Tuanzie hapo. Sodium readily reacts with oxygen to give sodium oxide and sodium peroxide. Magnesium reacts with oxygen to give magnesium oxide. Aluminium reacts with oxygen to give aluminium oxide. Silicon reacts with oxygen to give silicon 4 oxide. Phosphorus reacts with oxygen to give 2 oxides, phosphorus 5 oxide and phosphorus 3 oxides. And at which point can it give phosphorus 5? When oxygen is in excess. But when the oxygen is limited, it gives phosphorus 3. Likewise to sulfur, it gives sulfur 6 oxide and sulfur 3 oxide. But when you burn it, it gives you sulfur 4 oxide. So sulfur 4 oxide undergoes oxidation to give sulfur 6 oxide. Chlorine, under normal condition, do not react with oxygen. But under special conditions, in presence of a catalyst, it gives oxide of chlorine. In that case, it is oxygen that gains electrons, that produces electrons to chlorine. Now, what about reaction with water? To us and sodium. Sodium reacts with water vigorously, and we know that. Are you together? To give sodium hydroxide. Magnesium reacts very slowly with cold water, and silicon, phosphorus, sulfur and and tuachie hapo kwa sulfur do not react with water. Chlorine reacts with water to give two things. Na hiyo nilisema jana. Chlorine ina react na maji ndio ibeane nini? Hebu tuseme chlorine reacts with water to give type for me 2 products on the comment section produced when chlorine reacts with water. Jana niliandika hiyo equation hapo for ubao. Sawa. Twende another thing. Reaction with dilute hydrochloric acid. It reacts with hydrochloric acid to give sodium chloride and hydrogen gas. Magnesium reacts with H and hydrogen gas. Aluminium do react but very slowly with HCl. Are you together? To produce small amount of hydrogen gas and aluminium chloride. Sasa silicon do not react. Phosphorus no reaction. Sawa. Mpaka mwisho no reaction. Argon, of course, in most cases there is no reaction. Are we together? Yes. Question ya nursery. I'm just asking. Give the observation made burns in excess oxygen. Give observations made when magnesium burns in excess oxygen. Sodium chloride. So yes, okay. I'm getting you, Timothy. Very well. In short, magnesium burns with a brilliant white flame, light. Yes, which is magnesium oxide and magnesium nitride. That is in air. Lakini kama ni oxygen peke yake, magnesium oxide. Sawa. Aluminium tarnishes after some time. Why? I'm gonna explain. Aluminium ikiwa tu ndio imekatwa hivi ama imekuwa scratched, iko shine, lakini after some time ina tarnish. Reason is because of a layer of aluminium oxide in it. Sawa. Silicon reacts with oxygen. I'm giving you facts, things that you need to know. Silicon reacts with oxygen only under high conditions of high temperatures to give you silicon 4 oxide. And if you ask, at which temperature does silicon react with oxygen? Unasema 450 degrees Celsius. Sawa sawa. What about sulfur? By the way, hebu mniambie, what is the color of sulfur burning? Okay, when sulfur is burned in oxygen, what is the color produced? Yes. When you burn sulfur in air, in oxygen, what is the color of the flame produced? What is the color of the flame produced? What is the color of the flame produced? Yeah, you write it blue flame. Blue flame. Yes. Another question. Now, I want to give one concept, the rate of reaction across the period. Now, we only compare the metals first, then we compare the non-metals. So for the first metals, silikuwa tatu hapa, we had 3. We had sodium, then followed by magnesium, then followed by aluminium. Give the rate of reaction. As they move across, the rate of reaction decreases in a decrease, meaning sodium is more reactive than magnesium followed by aluminium. Hapo tuko pamoja? Yes. Why? Giving a reason is the most better thing that we need to give. Just a minute. Now, angalia hii. This one is only supposed to lose 1, this is supposed to lose 2, this is supposed to lose 3. So, this one has a high electron. Sorry. Ionization energy. E iko na high, followed by this. So, sodium has the lowest ionization energy compared to the others. Now, ukishafika hapa, so mnakumbuka hapa tuko na silicon. Now, wachana na silicon. Tuendelee na hizi zingine. So, hapa tuko na phosphorus, sulfur, chlorine. Again, when we are comparing the rate of reaction, wachana na argon. Argon do not react. Na wachana na hii. As you are moving this way. Kwa metals ukienda hivi, the rate of reaction decreases. Sawa. Lakini for non-metals, you move from phosphorus towards chlorine, the rate of reaction increases, meaning chlorine is more reactive than sulfur and than phosphorus. Why? Electron affinity increases. Electronic affinity kidogo tu. Good. Kuna concept fulani Nataka nipeane kidogo na mwelewe. Ni ya form 1 actually. When these metals react with oxygen, it gives metallic oxide. When these non-metals react with oxygen, it gives non-metallic oxide. When you dissolve these metallic oxides in water and they dissolve, I'm talking about those that dissolves, they produce a basic solution. Non-metals, when they're oxides, when they dissolve in water, it gives acidic solution. I'm praying to God that you know that one. Sawa sawa. Na watafute swali moja ya mwisho alafu tuende, alafu tufunge lesson ni leo. Okay, ndio nimepata. Give the name of the product formed when magnesium reacts with phosphorus. Hii ni ya mwisho. Kuna swali nimewekea hapo. So give the name of the product formed when magnesium reacts with phosphorus. I want us to give the name and we write the equation. Alafu tumalizie hapo siku ya leo. We have magnesium solid to react with phosphorus. Phosphorus is also solid. It gives what? Kwanza, before tuandike formula ya hiyo compound, what is the valency of sodium of magnesium? Magnesium iko na valency ya 2. Phosphorus iko na valency ya ngapi? Phosphorus iko na valency ya 3. So the compound formed, it exchange the radicals. Oh, sorry, the valence is this way. So we will have magnesium 3 P2. Sawa? That is called magnesium phosphide. This is called magnesium phosphide. Magnesium phosphide. Kumbe Timo hiyo swali umepata vizuri, magnesium. Lakini hiyo spelling ya magnesium. Okay, nobody will ever question you about the spelling. It's just on a light note. Magnesium yaandiko hivyo lakini ni sawa. Sisi na ubaya. Haya, thank you. Next week, because this weekend we will not have a lesson. Even the show that you always do for your parents and your elder sisters and brothers, we don't have it. Hii weekend tuko held up kidogo. I will be traveling to the city of Eldoret to do something there. Then on Monday I will be coming. So see you on Monday. We discuss chemistry again. From next week I will get an extra time to be discussing physics also. So what am I saying? Keep joining me and thank you for being on our side. If you are new in this channel, please check on all our over 200 videos in our channel. Check on those chemistry lessons, physics lessons. Check on those motivation talks given by me and other people that I always invite. Check on even the events for schools that we attend. I always attend to various schools and capture their events. In your school where you are, you can tell your teacher or your principal to seek us. We come and do that work, we live stream in your school. Otherwise, I'm so grateful and we are out in 3, 2, and 1.
We will get